Induction motors have been ruling the industrial world for many decades. In the induction motors used in lift and hoists, you will see a type of rotor called a slip ring rotor, whereas in most of the other applications, you will see a simpler squirrel cage type of rotor. Why are there two different designs of rotor construction for induction motors? We will explore this in the video. Normal induction motors, or squirrel cage type motors, produce a very low starting torque, and for some applications, this low starting torque will cause huge problems. It is in these circumstances that slip ring induction motors are used, as they produce high starting torque. Let's see this in detail. First, let's have a look at the way a squirrel cage induction motor works. When a three-phase AC supply is connected to the stator winding, it produces a rotating magnetic field in the air gap between the stator and rotor. This RMF cuts the rotor bars. According to Faraday's law of electromagnetic induction, an electromotive force is induced in the bars. Because the rotor bars are short-circuited by the end rings, this induced EMF generates a current to flow through the rotor bars. According to Lorenz's law, when a current-carrying conductor is placed in a magnetic field, it will experience force. You can see the force distribution on the different bars at a particular moment in time. These collective forces make the rotor turn. This explanation of the way an induction motor works won't be complete without an understanding of the concept of inductance. To understand what inductance is, let's consider a simple circuit. The circuit is a combination of a resistor and an inductor in series, which is connected to the AC sinusoidal voltage. Let us connect a phase angle meter to the circuit to measure the phase difference between the applied voltage and the current. You can see that the current flowing through the circuit is not in phase with the applied voltage. This is because of the presence of an inductive reactance in the circuit. The higher the frequency of the electricity, the greater will be the inductive reactance and the phase difference. A higher resistance value reduces this phase difference. The exact same thing is also happening in the rotor. The rotor is a combination of resistance and inductive reactance. Due to the same phase lag phenomenon, if the maximum EMF is on one bar, then the maximum current will be on another bar. Now, here is one interesting fact about induction motors. An induction motor produces maximum torque when the maximum current induced on the rotor is near to the maximum magnetic flux. This fact is clear from the comparison of these two visuals. Let us call it the maximum torque condition. Throughout this video, please keep this fact in mind. As the current induced does not meet the maximum torque condition, this will definitely reduce the amount of torque produced by